Hi everybody and welcome to the SaGe-Path demonstration, a pay-as-you-go SPARQL Property Path Query processor using Web Preemption. So the topic here is the processing of Property Path query on online endpoint. Property Path queries are queries that contains Property Path expression, like here, this expression. This query computes the creative works with fictional works that inspired them. And as you can see, we have a transitive closure on the subclass of predicate. So these queries are very nice for exploring graph, but can be very long to compute. And on online SPARQL endpoint, you have problem of fair use policy. So basically, public SPARQL endpoint will kill the queries after a maximum time. For example, here I executed this query on Wikidata and this query takes too much time. So the query has been killed after 60 seconds, only delivering partial results. So the problem here is now how it's possible to compute a property path query online and get complete results. That's the objective of the demonstration. So here we are using two things. Third thing is Web Preemption. So Web Preemption will stop every query after a quantum of times, allowing them to restart later. For example, here I set the quantum to 1 second 5. So it means that the server will stop query after 1 second 5, but you can restart them later. So the effect of Web Preemption is that it's not possible to block the server more than 1 second 5. That's very important. That's the first ingredient. The second ingredient is max-def. That define in fact the partial transitive closure. That is fundamental for our approach. So it means that with a max-def of 5, when we'll execute this query, we will explore the graph at a maximum depth of 5. Okay, so we will just get partial result, all results that are reachable with a max depth of 5. And of course, after that, the game is to continue the executions. So let's start executing this query with a max depth of 5. Okay, it starts. Okay, it's finished. So first, it means that with a max depth of 5, I nearly got all the solution, because here I have all the mappings that are reachable with a max depth of 5, which is almost all the results. Okay, so I got first result very early. That's the first nice things with this approach. And after that, of course, I'm not sure that I get complete results. So I have to continue the query from the point where I have been stopped. So let's look at the first subquery we have to execute. So this is the original query we executed, but in fact we have been stopped when visiting this node. Okay, so it means that the frontier node here, it means that when we reach this node, we reach this node at a depth of 5. And the state of the other variables when we reach this node was this one. Okay? So if I execute this query, I will restart the execution of the original query, but now starting from these frontier nodes. Okay? And maybe I will get new results. So let's do that. And okay, I have no new results, but I made a progress. Now I have still 43 frontier nodes to examine. So I can do that next, and of course I make progress. As you can see, we have statistics behind that are evaluating data transfer, execution time, and number of HTTP calls. And for data transfer, we have three things, in fact: control tuples, duplicates, and solution mappings. So of course, to execute such query, we are sending control tuples, allowing the clients to generate all these subqueries and guaranteeing to the client to terminate the query. Okay, so I will execute everything now. And in fact, yeah, it is progressing. And in fact, there was 62 solutions. So we got all the mappings from the first call, but it was not sure. So by examining all the other subqueries, now we are sure that results are complete. And we have all these results. So now let's look what happens if I make max depth of 10. Okay, so I will execute with a max depth of 10. So I start executing. So as you can see, we started the second column. So it's easy to compare the performance with the previous run. So now, of course, we have less frontier nodes because we are exploring with a higher depth in the graph. So as you can see, so I can execute because there are not a lot of queries. So okay, I finished. As you can see, with a max depth of 10, it's much more efficient to execute a property path. In the demonstration, you can set your max depth and quantum, but in fact, these parameters are not under the control of users. It's parameters that can be set by the server administrators. But to show you how things are behaving, we let you modifying these parameters from the user interface. So, for example, I can put a smaller quantum. So now it means that I cannot block the server longer than 150 milliseconds. So it's very good for having first result very early. But of course, maybe we will have more HTTP requests to complete. So let's do that. Okay, so it's quite fast. And at the end, okay. So having a small quantum for this query, it was okay. But it does not mean that it is okay for all queries. Okay, now I can see what happens if I put a small depth, maybe 3, and execute. Okay, so we have more frontier nodes with a small depth. Okay, and with this depth of 3, I don't get all the solution mappings after the first query. So now I can execute the rest. Of course, small quantum, small depth, you have more calls. So you have more control tuples. So it's quite logical. Okay, and that's it. So when you have very small quantum, small depth, it takes more time to execute, more overhead in data transfer, and more calls, which is very logical. Okay, so I hope it helps you to understand how SaGe-Path is working. And the final message is that thanks to SaGe-Path, it's possible to execute very complex property path query online, get complete results, and all of that without ingesting dumps locally. So I think it is quite useful. Thank you for your attention.